In this video, we'll look at question 49 from the 2016 paper. So basically in this question, we have a cursor probably on a screen, which starts at this position 10, 0, and then moves to a negative x direction parallel to the x-axis, while at the same time, up on the screen, we have this blue curve, and we know the equation of this curve. We are supposed to say, well, the minimum vertical distance between the red and the blue line, so the position of the cursor and the curve, will be as it moves to the negative direction. So as you can see, the distance is, the vertical distance can be represented like this, and the length of that line, let's call it d, well, that's 10 minus the y-coordinate of this point on the blue curve, which is directly below the corresponding red point from which we are measuring the distance. Now, for which negative x is d the smallest? That's an optimization problem, and to solve it, we'll need to find dd by dx. Set the first derivative equal to 0. So this is the function d differentiated with respect to x. It can be simplified to 0 equals x squared minus 2x minus 3. So we basically divide it by negative 12. And now that factorizes nicely to x minus 3 times x plus 1. And remember that we're only interested in negative x's, negative stationary points, or more precisely, their x coordinate being negative. So what is d, the distance between the two curves at x equals negative 1? Well, it's 10 minus 4, then minus 12, plus 36, minus 15, and that gives us 5. Whoops, 5 like this. So that's the minimum distance from the cursor to this curve, 5, and that's our final answer in the exam. It was option B.